We're now going to look at summing a GP. Remember, a GP has a common ratio. And because of the ratio, and the ratio could actually be a fraction, then we get some very interesting situations. So, you actually see that we need to consider the two situations. One when the ratio is a number greater than 1 or less than -1. So as it's shown in the notes, it has an absolute value greater than 1. That just means, like I said, it's a number greater than 1 or it's less than -1. And then we also need to distinguish that from when the ratio is a proper fraction. Some interesting things happen when we have the ratio as a proper fraction, and you'll see that in the next exercise, and it only occurs when we have a proper fraction as a ratio. But for now, let's focus on finding the sum of a GP. So it all depends on the size of the ratio. So clearly we have to have identified the size of the ratio. Now, again, these formulas are given on the reference sheet. No student should be ever writing the formula incorrectly, because you've got it written on a sheet and you should be accessing that. Access it in class, use it while you're doing your homework, then it becomes automatic that you're looking for it in an exam, and you'll be using the correct formula. And the reason I'm emphasising this is because I've marked work where students have not written the formula correctly. Now that's really just throwing away marks. What does it look like? So if we've got this situation where the ratio is a number greater than 1, then the sum to n terms relies on the first term, the ratio to the number of terms, subtract 1 all over r minus 1. You might be able to see there that because the absolute value of r is greater than 1, then we will have, generally, we will have a number that's positive. So if r is 2 subtract 1 is a positive number here. In the other case, when r is a fraction, the sum, top line changes for the sum to n terms, a times, this time, 1 minus r to the n. Because remember, r is a fraction, so we want to keep this positive, and 1 minus r, a fraction, will be a positive number as well. So, they are the two formulas, and there's not much more to say other than identify the ratio, choose the right formula, and then be very careful. There's some interesting things to note about the sum of a GP. If the ratio of the GP is 1, and I guess that's possible, unusual, but the ratio could be 1, then the formula doesn't work. Why? Because if it's 1, 1 minus 1 is 0, and we'd get a 0 here, and you can never divide by 0. Does that mean then that you can't sum a GP where the ratio is 1? No, that's not correct, because if we had our GP as this situation here, where a is equal to 3 and r is equal to 1, this is what we're considering, then the series would look like, for the sum to 1, 2, 3, 4, 5 terms, the sum to 5 terms would actually look like that. So it is possible to get the sum of the terms in a GP when the ratio is 1. Unlike the formula would be suggesting, the sum is undefined, because if I sub into the formula, I'm getting a 0 in the denominator. We can see there is a definite answer. So in this situation, what would the answer be? Well, hopefully you can see it would just be 3 times 5. Each term is 3 in this example. There are 5 terms, so we've got 3 times 5, or 5 lots of 3. So the sum to 5 terms is 15. So we then conclude, if r is equal to 1, all the terms would be a. As you can see, all the terms are a because the ratio is 1. So the formula for finding the sum to n terms would simply be a times n. Now, while I haven't seen that question ever appear on a trial or in a HSC or in an assessment task, that doesn't mean that it may not. So it may be just a matter of time before it does turn up. Just be aware. The ratio of a GP cannot be 0, as all the terms would be 0 and the ratio would then be undefined, because we'd be trying to put, so if we were thinking that this was our series, then we're trying to put, we know that r is T2 over T1. We're trying to do that any time we put a 0 in a denominator. Our concept is undefined, so the ratio is undefined. Hence, there is no such thing as a GP, or no such series or sequence as a GP with ratio 0. You again heard me in class point out the importance of doing this and reading the question carefully, and always write down the information in symbolic form. Well, symbolic mathematical form. I was referring to this as your problem-solving techniques, and this is an excellent chapter to really develop good problem-solving techniques. Paying attention to detail, reading the questions carefully, extracting every little bit of information out of the question, and you will only do that by paying attention to detail. Writing everything you possibly can in mathematical form from the information given. All of these things are really building your problem-solving techniques, which you will take to every topic. Okay, so just for example, it says, if it is given that the sum of the first 4 terms of a GP with ratio 3 is 200, then you can see what I've said to write. To me, this question is very heavily worded. It's got a lot of words. It doesn't have any, it's got 2 numbers, but that's as much as it looks like maths. However, when I look at this, it's looking much more mathematical. Now, this is not going to necessarily be given. However, once you get that, it somehow seems a whole lot easier to know where you're going than just trying to work with the sentence. So that's what I mean about taking the information and translating it mathematically. So if it's given that the sum of the first 4 terms of a GP with a ratio 3 is 200, then first time through I'm going, well, the sum of the first 4 terms, that's called S4, and I've got to get through this little bump to know what it actually is 200. So the sum of four terms is 200. Let's go back. There's more information which I just got through to get to be able to write that much. The ratio 3, so r is equal to 3. Now, so I've now got this and I've got this. This we have to know to make this connection. Sum to four terms is 200. Why did I write this? Because we have a formula. If you don't know that a formula exists, you won't make the connection. And this is what I also said in class. You have to know these exist. They have to be familiar to you. And in this case, they exist and they're written on the reference sheet, which makes it really easy. So knowing this formula, well, actually there are two formulas. Which one will I choose? Again, you've got to know the fact that you will choose when the ratio is a number greater than 1, you choose this format, which you can see I have based this little equation on here. So it's A times, the ratio is 3, n is 4 minus 1 over 3 minus 1. Hopefully you would see then that we've got one unknown here, A, and S4 is actually not an unknown because we've got 200. We could sub our 200 here, create an equation just in A. An equation with one unknown, we solve. Okay, I think I will stop the video there and you talk about the examples in another video.